to guess, about 700 milliwatts out of it. There's probably other ways of getting more power out of it because it claims to be 1200 milliwatts, but then again, we are talking about an alpha clone and not an actual alpha. But then again, it only cost me $11 with free shipping off of eBay. I might decide to go to something a little bit better like an actual alpha, but this was just something I wanted to set up to see whether or not we could really do what we had hoped to do with a friend of mine's wireless connection. So, unlike a lot of these other videos that will, ramble on, I'm going to try and give you some information about how to put something like this together. You will find in the bottom down there the links to how I put some of these components together and how it ended up. I'm going to go ahead and give you a couple of the inside ideas on how to resolve certain issues. The first thing I want to go ahead and talk to you about is the feed horn that we're actually using, which is a cantenna. Again, all the instructions are down below. What I had found out of all the kind of cantennas that I made for this, that the best can that seemed to work out, mostly because of its diameter and its length, was the Bush's Baked Bean can. It has an inside diameter of 3.28 inches, and it seems to put it right in the middle of the spectrum where you need to be. The element in itself is now sitting, I believe, 2.24 inches from the back of the can. I tried larger cans, I tried smaller cans. I was going to do a Pringle can, but Pringle cans are not really weather resilient. They're just not going to hold up. You want to go with a can and then paint it up and make it nice. The plan eventually is to go ahead and put a cap on this end. Right now it's open, and utilize it as a permanent fix once it gets all mounted to the roof. Right now we've just got it mounted to a pole. Again, we're talking about a DirecTV antenna. One of the important things you need to know about DirecTV antennas and their like is that they are offset, which is, you notice that the feed horn is down at the bottom of the antenna instead of directly in the center. That is because the parabolic curve of the antenna is designed for shooting up into the sky and not have the signal blocked by the LNB that is normally connected to this portion here for receiving satellite TV. It means that you're going to have to turn the unit upside down to be able to use for terrestrial work. Otherwise, you're going to end up having to have this antenna, the parabolic portion, facing the ground, and unless you put a cover over the end of your feed horn / antenna, water's going to get in it. So flipping it upside down suddenly turns it into a terrestrial antenna that works really, really well. As it stands right now, I'm getting about 28 dB gain on this antenna, although it is highly directional. I will say that your maximum directionality component of using the maximum amount of gain that you can get is always going to come from parabolic dishes. You're not going to be able to get the kind of gains out of things like Yagi and that sort of thing unless you go really big and you go with really high-powered adapters and that sort of thing. But this is a straight build. This is a junk build. I believe that out of this with connectors and everything, I maybe have about $20 in this entire thing. And I'm getting 28 dB, sometimes a little bit more, sometimes a little bit less, depending. Right now I've got this simply mounted on this wire armature so I could bend and play with it and see where I was. Now I'm going to give you a little trick about this, setting up a parabolic dish. I took some reflective tape and I put it on the 4 cardinal points on this first, and then during bright sunshine, aim the dish at the sun. And what that ended up doing was, because of the reflective bits on the 4 points, you end up being able to figure out exactly where the focal point is, where all this radiation focuses to. Now you have to try and center it up as much as you can with the sun, and it's going to go up and down this way, but you're going to end up with a focal point. And once you figure out where that distance is, the actual distance from the center of the antenna to the focal point where all the radiation is being coalesced, that is where your opening for your antenna should be. It shouldn't be any farther in or any farther out. It should be right on that focal point, which is where we are at the moment. This is all going to be eventually mounted a little bit more solidly. We're going to move from this. Now that I have all my angles right, I'm going to be actually building a hard component that will actually support the antenna, and we're going to be getting this up on the roof. This component here, namely the alpha clone adapter here that we've got, it's been working good so far. I've used this for other things. I've actually been using it with a Yagi that I had for a long period of time. It's been working for about 4 months, so I haven't had any problems with it. But again, you know, Alpha is a brand name that actually is a very good product. I highly recommend them. For this project, I wasn't going to do anything about that. All right. So some more particulars about this. We have, of course, our super long USB cable. Now, a lot of people get this wrong. They think that, you know, they can just use a super long straight USB cable. You cannot use just a straight USB cable. There's way too much internal resistance in the wire, and what you end up having to do is get something like this. I'll try and get this to focus, excuse me, and the potato quality of this. All right, you may notice this little black box on the end of this cable here. What that is an extender. It uses the 5 volts off of the USB line to actually amplify the signal, so you can use a super long cable like this. This particular cable is 30 feet long. I've seen them up to 50. I don't know about the performance at that length, but I can say the 30-foot version works fine. And it works with all the adapters that I have. And it was a straight plug-in. It actually showed up as a USB hub when I plugged it in the first time, and it's been working fairly solidly ever since. Now, again, this is the sort of the cable cut sort of situation that we're doing now. Eventually, I'm going to be moving completely away from paying Comcast anything eventually, and we're doing some testing now with a friend of mine who happens to have gigabit Ethernet, and right now he's about 2 miles from me, and as a straight LOS shot, once this is on the roof, right now I'm getting about 15 megabit, and after we get it on the roof, I have a feeling we'll probably move up to about 20 to 30 megabit down, about 10 megabit up continuously. And since I'm going to be more than willing to pay him, $20 a month just to not have to deal with Comcast ever again while he is on his industrial strength gigabit net, I'm all for it. Okay, just I want out from underneath Comcast, and I think a lot of other people do as well. So they are just simply saying screw it. That's about it. Again, most of these components can be found, again, Bush's baked bean can, the large baked bean can. Any can about the same size that is anywhere from, let's say, about 3.24 inches in diameter to 3.33 would be about right. It puts you right in the frequency range that you need for 802.11b. And again, at least on this can, we are 2.24 inches from the back of the can here. All right. So there you are, $20 worth of materials, a little bit of dumpster diving, a little bit of junkyard, and